a few problems in the intersection of internet commerce and healthcare. You should be hearing about this a lot more today. So my topic for today is it's unusual for a conference of software architects, right? But then I figured this is not just a meetup of platform architects, right? So we are architects in general, which means that you also be interested in, so if you have an analytics platform and there is a talk on analytics platforms in the afternoon. So once you have an analytics platform, what do you do on top of it, right? What kind of analytics do you do on top of it, right? And I figured a lot of people would have heard about things like machine learning, you would have heard phrases like text mining and big data and stuff like that. So I figured why not introduce a new concept, right? So what I'm going to do is I'm going to talk you through some an approach for doing some text mining, right, in social media, right, using what I call a cognitive approach. Okay, so this was part of my PhD a few years ago. And I've quietly evolved this concept as I've gone along. So let's try to make this interactive. I have 40 minutes, right? 45 minutes. So let's make it 35 plus 10. What's the time? Okay, alright. So let's make this interactive. So I'm going to concentrate on three things here. One is that there is a cognitive approach, right? So we have text from social spaces. We are first going to define what is a social space. What makes it interesting? Why should we treat it very differently, right? Why not just look at it as text, right? That's one. The second is that we are going to be looking at mining some sort of structured semantics from it. And our way of doing so would be by using some sort of a cognitive architecture, a cognitive approach. Right, so let's just get down to business. Okay, so what is the social space? Social media, right? But social media generally has this connotation that it's just Facebook and Twitter, which is not, right? We have blogs, we have discussion fora, there's Twitter, there are wikis. Wikis are great social spaces, and so on, right? Now, what is common to all these different kinds of, let's say, content platforms, right? What is common here? The commonality number one is that content is created by humans, right? It is not arbitrarily created content. And how does this content come about? So, suppose you have a blog, right? When you start writing a post, it's not that you're just typing away and words are appearing, right? It's because you're thinking, right? You're thinking about something. There's a cognitive process that's going on inside your brain, which is responsible for the content being produced, right? Now we are going to hold this cognitive process as some sort of a base, right? Around which we are going to try and build a computational model, right? So it's something like this. So you're thinking, right? The brain does all that exercising and produces opinions and debate and argumentation, right? Which is how cognitive processes manifest themselves. Commonality number two is that there is social interaction between cognitive processes, right? In these social spaces. For example, you write a blog post, somebody writes a comment to it, right? You write a Facebook post, and then there is a comment to it, right? And especially these days on Facebook, so there are the warring factions. One is entirely pro a certain politician, and the other one is entirely against a certain politician. One group writes a comment, the other one is directly attacking the other. So this is an interesting phenomenon, right? So there's a lot of social interaction happening between their cognitive processes, essentially, right? So it works something like this, right? So to start with, somebody, decided to, so somebody was thinking about something and they decided to share their excitement about some stuff that they brought from their hometown, right? So let's say, and this is an actual tweet, this is not manufactured, this is an actual tweet. So this guy, he tweeted, so Mutalikdesai, you guys know these things, right? Okay, anyone who doesn't know these delicacies here? Okay, alright, so we probably talk about it. These are must-haves, right? And they're native to Karnataka, Bangalore especially, we'll buy this one, right? potato wafers, and he's brought all this stuff from home. I don't know if it's a pure Russia, and she brought this stuff from home, and she's excited about it. She said, "This is good stuff. I like this." Right? To which, of course, you write something on Twitter, somebody has to reply. Right? So it's like, "Hey, I did this today. Like, why did you do that?" Right? So somebody has to say something. Right? Somebody has to say something. And, it is also pretty ridiculous because these days it's like I took my dog out for a walk, right? And this is a Facebook post, okay? And then there is a comment to this: how many paces did you walk, right? So what are you concerned about there? The guy who took the dog out for a walk, or the dog itself, right? So there is a lot of this back and forth that happens on social media these days. So in reply, somebody must say, and this guy is a minor Twitter celebrity actually. He says, if you chop some, this probably into little bits and serve it with ice cream, it tastes even better. Right? So what happened here? This person shared their excitement. This is their worldview, right? That all this different stuff, this is all great stuff, it's very tasty stuff. And this guy has a worldview that if you chop up some of this programming and mix it with ice cream, then it tastes even better, right? So that's an opinion that he is forming. And together here, we have social interaction between these cognitive processes, right? Now this is what we are going to leverage. So we started with the cognitive process. We have established social interaction between these cognitive processes, and we are going to now try and leverage this model. So what do these cognitive processes do? They basically are a means for you to exhibit your worldview, right? So any individual can make an assertion that corpora tastes great with ice cream, or corpora is not a good dish, right? It's an individual's worldview, need not necessarily be the truth, or that's a worldview that need not be held commonly by the population at large, right? So one person's cognitive process is basically that person's worldview, right? So a bunch of cognitive processes make up that person's worldview. That's their outlook towards the universe, right? But so now we need to talk about semantics, right? We said we will explore structured semantics and all, and that looks like it's kind of taking a backseat. So let's bring it to the fore here, right? Now, what I'm going to assert is these individual worldviews, right? These contain semantics, right? For example, somebody says that corpora tastes great with ice cream, right? They're basically saying there is a triplet here. They're saying, okay, so there is a concept A and there is a concept B, and there is a relationship that is connecting them together, right? So that is how they're making a statement. That's how they're making a triplet, right? So that's a semantic association. So our worldviews are basically a collection of semantic associations, right? So A is a great phone, right? Is a great phone, right? That's a triplet right there. That's a semantic association. Or it is like saying person A is a good leader, right? Leader, person A, two concepts which you are connected with an association, right? So that is how we construct our worldviews, right? However, we have to be very careful in reminding ourselves that these are individual worldviews, right? So even though these individual worldviews might contain semantic associations embedded within them, they may not be semantic associations as held by the population at large. Right? These are not commonly held semantic associations. These are individual worldviews. So we should say, so semantics are those that are applicable across the population, right? So then what we'll do is, we'll say semantics are those associations that are commonly held by the population, right? So for example, you could simply say, if you have 100 people, there are various ways of modeling this. The simplest way is to say, you have 100 people in this population. If more than 50 hold a particular worldview, let's consider that to be a globally held worldview, right? So that's a very, very simplistic way of looking at this, right? So now, if you ask, does the population at large think that the Apple MacBook Pro is a great computing device, right? And if they do, then yes, that becomes a a global semantic. That becomes a global semantic association, which is true, in general for the most part, right? There will be a few haters of MacBook Pro every now and then, but for the most part, it seems like it is a good device, right? So that becomes a global semantic association. So far, are there any questions? I mean, are there any comments? Yes, no, no. Are you guys alright?
Yeah.
Yes. Okay. I had to ask that to make sure I was awake and wasn't just talking in my sleep. So, okay. So just to structure that definition a little bit, because we put it in very casual terms, what semantic association is. So we'll just say it's a triplet, right? It's a triple essentially. Concept, two concepts with an association type in between. So Galaxy S3 is a great phone, right? Is a great phone. Great phone itself could be a concept, right? Corpora tastes great with ice cream, right? Okay, so now we've seen previously what gives rise to these worldviews, the individual worldviews, right? And then there's social interaction that happens between these cognitive processes, which essentially tries to bring out a shared worldview, right? So somebody wrote one tweet saying Corpora is great, and then this guy said it tastes great with ice cream, and then maybe that person will try it and say, oh, yeah, you're right, and I'm sorry, my phone is ringing. Right, so somebody's, and then maybe this person will say, yeah, let me try out Corpora with ice cream, and maybe it will taste great, and it does, right? And they tend to agree, and they come to a consensus, they come to a shared worldview. Or they will say, no, it doesn't taste great with vanilla ice cream, it tastes great with chocolate ice cream. And then there's a whole discussion around it. And there is a shared worldview that emerges, right? So there's an interaction between these cognitive processes which leads to the emergence of these shared worldviews. These shared worldviews may not be something that you find actually in the universe of discourse, right? For example, in a discussion about let's say in a discussion about the law about the Constitution of India, it may turn out that the commonly held worldview is something about capital punishment, right? And that's a worldview that the population holds at large. They might decide that, okay, so capital punishment should be given only in the rarest of rare cases, but not otherwise. And rarest of rare means the following, right? Now this is probably not defined anywhere, but the discussion has given rise to that. So it is emergent, right? So it's a larger process. There is a socio-cognitive process. So you have a bunch of cognitive processes all interacting with one another. Together makes up a socio-cognitive process, right? So it will look something like this. You have your blog posts and comments associated with the blog posts, and all these interacting with each other. Together they form a socio-cognitive process. This is, let's say, this is one blog post along with its comments together, right? And then you take the entire set of blog posts and you have the blogosphere itself, which is what we call the social space, right? So again, sharing excitement, saying the corpora is great, the Corpora is great, and the guy says you have it with ice cream. So what is happening here is there is a socio-cognitive process. It's not just an interaction between cognitive processes, right? The interaction leads to socio-cognitive processes, right? So now we have established that when you see content, especially in social spaces, right? These are embedded in there due to socio-cognitive processes, cognitive processes, right? So it is the thinking of a person or a bunch of persons that is responsible for this semantics getting into the text in the first place. So now what we are going to argue is the best way of extracting them is to mimic that cognitive process, right? So traditionally we have techniques like machine learning, right? So machine learning, what will machine learning do? Supervised machine learning, for instance, will try to look at a bunch of patterns in text that you already have. It will try to learn those patterns, right? And then it will say, okay, now give me new patterns and I will tell you what kind of pattern it is, right? So you can, if you want to mine relationships, right? If you want to mine what tastes great with what kind of relationships from a bunch of text, then you could do this through machine learning. But the problem is that machine learning is limited by the fact that all your output it relies on the training sample that you have provided, the training set that you have provided, because machine learning algorithms are not capable of understanding why these semantics exist there in the first place, right? On the other hand, if we have a cognitive approach where the entire basis for the solution model is how the brain works, then you know why these semantics exist, and therefore you know how to get them out. Okay? So we'll, yeah.
It's like a graph of all this interaction where each of these connected to multiple nodes.
Exactly. So we will look at a kind of a graph there. Basically, this is a graph of co-occurrence. I'll just come to that. But yeah, you have the general idea, right? So now, so why not say machine learning? We just talked about it, and any other model, network model, generative models, right? They cannot explain to you why semantics exist. Okay, they will explain to you how semantics can be identified, but they cannot explain to you why semantics exist, and therefore may not work at scale. In identifying different kinds of relationships that have not been seen until that point. Right? So now what we are going to do is we are going to propose a method. It's a relatively simple method, which will basically mimic human cognition, right? To a fair extent. All right. Now let's do this exercise. Okay. So does Lala mean anything in anybody's language here? I hope not. Right. Let's solve for a moment. It does. Okay. Oh, you mean the said Lala? No. Okay. Let's assume that's white. Right. So or you can consider any other word here as a meaningless sound. Consider Lala to be a meaningless sound, right? And read that paragraph. It says there is something in my kitchen. In the morning, I made some tea in it, and it is made of very high quality stainless steel. It has a volume of 2.5 liters. What is that meaningless sound? It's a vessel, right? So what started off as a meaningless entity has acquired a meaning, right? How did you assign a meaning to it? Right. So there are other concepts here which are associated with Lala, right? So there is the fact that it is in a kitchen, right? So Lala is in a semantic relationship with kitchen. Lala exists in a kitchen, right? And it has a volume of 2.5 liters. It has a volume. So when you say volume, it has to be something that is a container, right? It is made of stainless steel and it is in the kitchen. So that is how you conclude that it is a vessel, right? So similarly, if I accept that my whatever Lala, Jabberwock, whatever, if it has 4 wheels and it gives me a mileage of 15 kilometers a liter and it guzzles petrol or something like that, you would guess Jabberwock to be a car, right? And nowhere did I say that it is a car, but it acquired a meaning there, right? So let's try and now mimic this process. So how did this happen? Okay, this happened because we looked at how that concept whose meaning is not yet known is co-occurring with other known concepts in that context, right? So Lala was a concept that had not acquired any meaning yet to start with, right? But then you saw that it is co-occurring with concepts like kitchen and volume and 2.5 liters and stainless steel and so on, and these are concepts that you recognize. You saw how this seemingly meaningless concept co-occurs with these others, and that is how you basically assign some sort of meaning to it, right? So the basis for this kind of co-occurrence analysis is one, cognitive science, as we have just seen, and I'll give you some more examples, and the other is ordinary language philosophy. So maybe we'll come to these in a bit. So the cognitive science aspect is like this, right? So this is cognitive neuroscience actually. So there's something called the Hebbian theory of cognition, right? So there is this neuroscientist called Hebb, and back in 1947, I think, he proposed a model for how the human brain works, and this is a fairly accepted model. There is still debate about it, but it's fairly accepted. He said it works like this. So semantic memory is formed when concepts get co-activated in the brain. Okay, let that not scare you. I will give you examples, right? So a popular phrase for Hebbian theory is cells that fire together wire together. Let's see how. Okay. Now, who else comes to your mind?
We do.
Yeah, Gabbar is already there. Yeah, so Hero comes to mind, and who else comes to mind? As soon as Hero comes to mind, Vasanti. Oh, Vasanti comes to mind. All right, see, okay, this is interesting. All right, so okay, see, Jay and Hero is what I had in mind, but then so he had Vasanti in mind. And then from Vasanti, there was what is the first name? No. Yeah. So this is what happens, right? Essentially, you recognize Gabbar, right? And you recognize Sanjeev Kumar, what is Thakur, right? Now, the thing is, you've seen both these guys in the same context. You've seen Thakur and Gabbar in the same context all the time. Have Thakur and Gabbar appear in different movies? No, you've always seen them only in Sholay, right? So now, what has happened is, every time you've seen these two, you've also seen this concept. That of Jay and Viru on the ridiculous motorbike, right? So what has happened is, so first time your brain saw Gabbar and registered Gabbar, and he said, okay, there is a neuron for Gabbar, it will fire. So when you show me the picture or when you give me any perception of Gabbar, my brain will fire and I will immediately recognize it, okay? And then similar thing happened with this one, with Thakur. Then a similar thing happened with these guys. But then what my brain noticed is, this is happening way too often. I mean, every time this guy comes up, this guy also comes up, and then this guy also comes up. Okay, so it figured they are somehow wired together. So then what it did is, see, these neurons ended up wiring together. So then every time, so now you didn't have to wait till you saw a picture of Jay and Viru for that neuron to fire, because those neurons are all now connected together. Every time you see Gabbar and Thakur, this will get fired. So there is a Sholay network in your brain right now. Okay, so that's how Thanno and Vasanti and AK Abgal's character, what is it? So all those come up, right? Similarly, what comes to your mind? Right? And we are unanimous on this. I'm very glad about that. Although there is that dog also, which is no, not Pluto. There is a dog. There's a dog that just keeps sleeping all the time, but then it wakes up, it starts chasing Tom. Right? Believe me, you are the first audience that has recognized that. Okay, so I was reading this on a similar topic. I was doing the talk, and I used this slide in an engineering college. Turns out nobody knew Laurel and Hardy, and then I realized I was in engineering college. These are kids. Okay, so they had absolutely no idea about Laurel and Hardy. I think some of them, if you and realize that there were comedy shows that were black and white. So yeah, so Laurel and Hardy, right? So your brain has always seen Laurel and Hardy in the same context, right? So when it sees Laurel, there is a cell that fires. When it sees Hardy, there is a cell that fires. But then they keep co-occurring together way too many times, in which case your brain decides to wire them together. So what it does, it then co-activates this concept. When Laurel is activated, Hardy is automatically co-activated, right? And it's not just how you perceive visually, right? This thing works with any other kind of example. For example, that Lala example that you saw, right? There was nothing visual there. We had to think, right? Similarly, what comes to your mind? There. So there's nothing visual there. I'm not showing you a mushroom cloud or anything like that, right? So Nagasaki does come to mind because it's co-activated, right? So now, what we are going to claim is, when concepts co-occur a lot, our brain tends to kind of co-activate them, right? So let us use that same concept, okay, and try to mine certain semantics. Now, the other basis for co-occurrence analysis, I mentioned cognitive science and ordinary language philosophy, right? The other basis is ordinary language philosophy. So, I think back in the early 19th century, there was this whole effort to lay the foundations of mathematics, which is when the set theory actually came about at that time to people like Georg Cantor, who eventually went mad because of what he proposed, right? So at that time, you guys must have heard about Bertrand Russell, right? Bertrand Russell, anybody? Okay, all right. Sorry.
But cannot.
Okay, so the thing is, in India, Bertrand Russell is more popular. He is actually a great mathematician and a philosopher, but in India he is popular for having appeared in a Hindi movie. Have you seen the movie? Maybe Google it. There is a movie clip with Rajendra Kumar and Bertrand Russell. It's very ridiculous, but then you feel great because there's Bertrand Russell in that video, right? So Bertrand Russell had a student called Ludwig Wittgenstein. Okay, so what that guy said is, so it's a meaning is usage, right? So how do you? So I think of any concept, right? I'll think of any concept, and if I have to assign a meaning to that concept, then how do I assign that meaning? I'll assign its meaning based on how that concept is used, right? That Lala example is a good example of this. Depending on how that particular word was used in that context, you decided to assign a meaning to that, right? So now what we are going to argue is that this co-occurrence lends meaning to a certain concept with respect to their associations with other known concepts, which is how we started, right? So we are going to try and mine certain relationships like describe and elucidate are synonyms, right? So now if I find the word describe, suppose there's a search engine where I enter describe and this is a search engine for synonyms, then I expect it to give me a result back saying elucidate is a synonym of describe, right? Lal Bagh is an attribute of Bangalore. So when you think about Lal Bagh, Vidhan Sabha, Kaman Park and so on, you think about Bangalore, right? So these are all attributes of Bangalore. So these are the kind of relationships that we are looking to mine, okay? So how much more time do we have? So you have 5 minutes, 10 minutes. Okay. Alright, so now I'm going to put forward some hypotheses, right, for certain kinds of relationships. Okay, so these are co-occurrence based hypotheses, right? So first is a hypothesis for identifying synonyms, right? So if you want to say A is a synonym of B, then what kind of conditions, what kind of co-occurrence patterns would you like to see, right? So I think the first condition or the first pattern that you would like to see is that these two themselves do not co-occur a lot, right? Because they are replaceable by each other. They are synonyms, right? So they are actually co-occur with a very low probability, right? That's first pattern. The second pattern is, so if A is co-occurring with a lot of other words and B is also co-occurring with a lot of other words, they have their own neighborhoods. These two neighborhoods are more or less similar, which means to say that they are basically co-occurring with a lot of other words which are, they are the same. So they are co-occurring with the same set of words, which is when they become replaceable by each other, right? The third is they have similar attributes, right? Which again, for identifying attributes itself, we can go into co-occurrence based hypothesis. But even if you leave this out, I've actually tested out these with these top two patterns, and it does work very well, right? So in February there was this hackathon going on at the IIIT Bangalore, and some 3-4 of us decided to hack up a synonym detector. And with just these two, these two hypotheses, we were able to identify a lot of synonyms with a fair degree of accuracy. The second is, how do you identify attributes? Okay, so if you have a concept like, if you have a set of concepts like Vidhan Sabha and Lal Bagh and Kaman Park and Bangalore or Palace and stuff like that, right? Also Lake and so on, then how do you identify that this is the set of attributes for a concept called Bangalore, right? So if you have a set of attributes A, right? This is all the Lal Bagh and Kaman Park and so on, and then you have another concept B, which is Bangalore. Now you want to establish that A is the set of attributes of B, right? How is that going to happen? So this is akin to that 20 questions game. So you know that question, that game where so you think of someone and you keep it in your mind, and I get 20 questions to arrive at the person that you are thinking about, and you can answer only yes or no, right? So suppose somebody is thinking about APJ Abdul Kalam, then I can start, okay, is it male? Yes. Is it Indian? Yes. And so on. Is it politician? Stuff like that, right? And then I'll arrive at APJ Abdul Kalam. Now what happened is, in this yes-no game, I'm basically trying to identify what are the attributes of that person whom the other guy has in mind, right? So that this is precisely how we play the game. So Now, so you say that A, so basically that set of attributes, that set of concepts, which maximizes the probability of guessing Bangalore. That is the set of attributes of Bangalore. So you take, if I take only, let's say if I take MTR and Lalbagh, okay, what is the probability you will guess Bangalore? It's very likely you will guess Jayanagar, right? But then I throw in Kaban Park. Now Kaban Park is not in Jayanagar, so you say, okay, this is not Jayanagar, so that is eliminated. Now you are getting closer and closer to Bangalore. So what is that set of attributes which maximizes your probability of guessing Bangalore? Okay, but actually trying to compute this, trying to find that optimal set which guesses Bangalore, that's an NP-hard problem.
So is that not something like this will depend on who you are talking to, right? Let's say somebody who is not from Bangalore,
correct,
and coming here and living in Bangalore for the last 1 year,
right?
So as soon as MTR and Lalbagh, first thing that comes in mind is Bangalore, not Jayanagar.
Correct. So, but that also depends on, like you said, it depends on the data set that you have. Now,
so if you average it, then you're saying that you tend more towards what you are saying.
Correct. So I'm saying that just MTR and Lalbagh are probably not sufficient to guess Bangalore, right? MTR and Lalbagh could. So if I give you Lalbagh and Kaban Park, would you guess Bangalore or would you guess Gardens?
Bangalore.
Okay, somebody else might say Gardens, right? Because there is no conclusive way of determining that.
Yeah.
But then I throw in more attributes into the mix. You start eliminating certain possibilities, right? Now the point is that if you want to actually compute this, if you want to write an algorithm for finding an optimal set of attributes which determines this other concept Bangalore, it is NP-hard. You can't do that, right? It will not run in polynomial time. Okay, so in which case you will need some greedy approaches. You will need some approximations of that algorithm. So to conclude, so the entire idea here is like this, right? So we have a co-occurrence graph. So this is basically, it is simply a graph capturing, there is concept A and there is concept B and concept C and so on, and how many times have each of these occurred with each other, right? Whether they have occurred with each other, and if yes, how many times. So it's just a graph capturing that. And on top of that, you have a hypothesis about the kind of relationship that you are trying to mine. So if earlier we saw about synonyms and attributes, so similarly you might have something else in mind, right? So once you have the kind of hypothesis that for the relationship that you are looking for, then the next step is, you have to algorithmize that, right? So for example, it is very easy to algorithmize the synonym hypothesis that we saw earlier because there is nothing fancy there. But the attribute one is very hard to algorithmize. It is NP-hard, right? The approach that the hypothesis that we take, right? And once you have that, then you have to test this hypothesis. And my PhD thesis was actually on the attributes hypothesis, and we came up with some greedy approaches for attribute detection. Worked fairly well. And recently I have tried out for synonym also. I keep trying out for different kind of relationships. It does work, right? So if you have some time, sometimes try it out. Try and build a co-occurrence graph for any text corpus that you have. Maybe just take a Wikipedia dump and try and parse it, right? Take all named entities in Wikipedia text and create a co-occurrence graph. So you say that named entity A and named entity B have co-occurred if they occur in the same document, if they occur in the same Wikipedia article. So build your co-occurrence graph that way and try and apply some of these hypotheses and see if it works. So our key takeaways are, cognition is what creates semantics. Cognition can be mimicked using co-occurrence, and co-occurrence hypothesis can lead to semantics. So whatever put the semantics in there, the best way of extracting them is to mimic that process.
Cognition, you said that it should be a triplet.
A semantic relationship is a triplet.
So if I say Samsung phone is awesome.
That is not that it should be, it helps to modulate that like that.
Okay, so if I say Samsung phone is awesome, so how do you?
So Samsung and phone are your concepts, right? So Samsung is a phone basically, Samsung and phone. And you are tying an association there saying it is a phone and that it is a great phone. It's an awesome phone.
Yeah, but it is afterwards, right? Samsung.
So that is a linguistic construct. So how do you parse the language is another matter. And we are not relying on the linguistic structure at all for mining these semantics. All I am interested in is whether Samsung, Awesome and phone have co-occurred together, and that is sufficient for me to mine that association. It doesn't matter how it appears. Even for that matter, the language doesn't matter, right? So it may as well be written in Kannada as long as they are concepts, and as long as I can measure co-occurrence between concepts, I can mine associations. Although, just to cover a few bases, it is not entirely true that the language doesn't matter, because it depends on the nature of the language. Kannada, for example, is an agglutinative language. We can fuse words together to make one new, entire word, right? It actually has multiple words fused together, right? So that is not possible in English. So it's an agglutinative language. So in that case, measuring co-occurrence becomes extremely difficult, because tokenization is a problem, right? So, but there we are still in the realm of NLP, right? In natural language processing. So if we have a way of parsing text, if we have a way of tokenizing text, then from there on, the language doesn't matter.
And the semantic, you have to come to a threshold value, right? You talked about semantic and then the synonyms. When you try to come to, you have to go to a threshold value, right? And then threshold value would differ for different type of words.
Exactly, yes. So there will be a few thresholds that you'll have to configure. So for example, we said that if A and B are synonyms, then A and B occur with a low probability. What exactly is low probability? Is it 0.1? Is it 0.01? What is it? So you'll have to put a threshold. So
and that will change from word to word, right? So then how do you generalize it?
I don't think it will change word to word like that. I think for the system as a whole, you can set one. So basically, that's a heuristic. You'll have to play around with it a bit and see how good the quality of results is. But you're right, there is an issue of setting thresholds, and there is no good way of determining thresholds ever, right? So wherever we use thresholds, there is almost never a basis for setting that threshold, right? So wherever anyone says threshold, try asking them why this number, and almost always there is no answer to it. Does that?
Will you be able to analyze the sentiment of that word? I mean, sentiment in that word, because I have seen some APIs called Sentigem and not providing whether it's a positive sentiment or negative. But it all depends on the context, right? It can be a sarcasm as well, right?
Sure. Yeah. So good question. I have not experimented with it, but I would like to think so. See, the difference between mining relationships and mining sentiments is, in fact, when he says, Samsung is an awesome phone. Awesome is a sentiment, right? It's a qualifier. Okay. Now, such things I am not entirely sure. See, as long as you can qualify sentiments also as concepts, as long as you can tokenize them as concepts, yes, maybe you can do it, right? But I'm really not sure. I'll have to try it out. The other APIs that you're talking about, the other approaches for sentiment analysis that you're talking about, they either mostly rely on machine learning, where they have said, okay, the occurrence of certain words and a certain pattern of words indicates a certain sentiment, right? So that is something that a model learns, an algorithm learns, and then tries to detect sentiment in other unseen messages. Okay, so that's mostly that's what happens. But with this kind of an approach, I'm not sure. I'm not sure how we can use co-occurrence to mine sentiments.
There have been some news articles saying Sanskrit is best suited for computer science. What are the meaning? And number two, you said Kannada because it can join multiple words. It makes it infinitely more complex. Since Kannada is also derived from Sanskrit, don't you think that that's not true? That it's not suited for.
So let's differentiate two things here. So one is a language that is used for computing. So we are talking about programming language there, right? The other is language that text is written in, which is basically our data set for computing. Okay, so I'd like to differentiate between those two. So when I said that the cognitive process model or this kind of a cognitive model, so tokenization essentially is a problem in Kannada because it is an agglutinative language. What I mean is the text of a data set is written in that encoding, in the Kannada language encodings, which are hard to parse and which are hard to tokenize, right? Now, whether that parser, whether you write in Sanskrit or C or C++ is another matter, right? And as for your first question about Sanskrit being more suitable, I am not an authority on that, and I will not answer that question, but I will refer you to a book. It's called The Skeptical Patriot. This book came out about 2 years ago, I think. It's written by a guy called Sidin Wadukut. He's a very good humorist actually. He started his career writing a series of humor novels, office humor novels called the Dark series. Okay, but if you can get your hands on that book, read it, because one of the chapters is exactly on this point. So whether Sanskrit is a new language, and whether there is a serious dose of patriotism that is fueling that rumor. So he has tried to answer such questions in as objective a fashion as possible. So that's the book I prefer to read. So does that answer the question?
So just wonder how frequently you should be refreshing your data set?
Okay, so that depends on how frequently your data set is changing, right? So, most often, so for the kind of analytics that I do, what I have to do is I have to keep crawling websites, or I have to keep refreshing the data set. Like you say, if you are using Wikipedia, for instance, you can get a Wikipedia download. You can download it, right? So maybe 2.5, 3 GB. No, in fact, more 60 GB. So you can download one dump, but that is the dump for the last month, right? And then Wikipedia is the kind of data set that changes every day, right? There's a lot of social interaction happening on Wikipedia, right? If you go to the talk pages on Wikipedia, you can actually see people, trying to squeeze each other's throats and trying to kill each other. That's the kind of intensity of debate. It changes very quickly, right? Changes really, really quickly. So next month, you better refresh that data set, because otherwise you're dealing with a lot of stale data. So it really depends. For example, if you are looking at internet commerce, if you're looking at Flipkart pages, then you would have to incrementally crawl the website, because product information doesn't change and there's no social interaction happening there. Right? Sorry? So you have to be very careful crawling reviews, because reviews are actually intellectual property of that website. Okay, and product information is actually encyclopedic knowledge, so that is okay to crawl. You have to be extremely careful when you crawl reviews, and even more careful if you are going to use those reviews in something. So yeah, the answer to your question is crawl it as often as it changes. Ganesh had a question. Sure. So business applications for this are, let's think of a company like Big Basket. Right, so there are great companies that are doing some awesome work. Big Basket Shop now, online grocery, right? Now they'd like to find out what is it that people are saying about them on social media, right? So it happens, right? So we tweet when we take our dog out for a walk, so we definitely tweet if Big Basket delivered at our place. So we'd like to see whether, as an analyst at Big Basket, I'd like to see if people are happy with my service. Right? And what other things are people associating my service with, right? Are they saying that they don't find wheat on my store? Or are they saying that the rice is good on my store? Right? So these are the kind of semantic associations that people will put on social media concerning Big Basket. And I'd like to mine them. That's very precious customer feedback for me to help me form a business strategy as well. So that you can think of umpteen such business applications, right? And for different industries as well. Since this talk was mostly focused on data that appears in social media, so it would probably be a lot centered on customer feedback and how you can improve your product strategy in tune with that.
So the examples that you gave, that can also help in like translation services where they do not know what the word is and they can understand according to the context. So has there been any effort in implementing this?
Well, I actually don't know the answer to that question. So about translations, machine translation still remains an extremely hard problem. Right?
Yeah, but from the cognitive approach, that is how the mind working, that is how we understand.
I can't be sure entirely, but if you've seen IBM Watson, there is a fair, I think there is a fair bit of co-occurrence analysis that they do there. Although I have not seen anything published anywhere about them using cognitive approaches, right? But then Watson seems extraordinarily intelligent for what he is, which is a computer, right? So I'm assuming that they are using that. So you are right. For example, I tell you this. So there was that game that they played, Jeopardy. They played Jeopardy, right? So Watson played Jeopardy, and so there was, so Jeopardy is a kind of game where you have to guess the question. They'll tell you the answer and you guess the question, which is I think harder, right? If you ask the question, giving the answer is easy. So the question was something, and the answer was it was something to do with the a dysfunctional limb, right? It was like a leg that was cut or something like that, or a limb in the leg or something. And Watson got to leg. Watson said, so his question was something about a leg, but it wasn't about a leg that was leaking, right? So yes, fair bit of machine translation did happen there, and maybe cognitive approaches can be used there, but haven't tried it, can't say. Thank you.